All right, so let's take a look at some trig ratios at the special angles. Okay, as we start to introduce the unit circle and the angles that you should be familiar with, and you'll need to be familiar with them next year as well in Calculus 2. But you should be familiar with all multiples of 30 degrees, 45 degrees, and 60 degrees. Okay? In terms of radians, that's pi over 6, pi over 4, and pi over 3. Okay, so let's start with a 30-degree angle. Okay, so if we look at this 30-degree angle, remember we're dealing with a unit circle, so the radius is 1. Okay, so if the radius is 1, then if you recall from geometry, the 30, 60, 90 triangle has a pattern of x, 2x, x root 3. Okay, so x, this side opposite 30 degrees, is always going to be half the hypotenuse. So in a unit circle, if your radius, the hypotenuse, is the radius 1, then that means the side opposite 30 degrees is going to be 1/2 of that. So 1/2 of 1 is 1/2. And then the side opposite 60 degrees is going to be this leg 1/2 times root 3. So that's going to be root 3 over 2. So notice that gives you the coordinates here of root 3 over 2 and 1/2. Okay, so when you're looking at this angle right here, what did we say that the cosine of an angle on the unit circle was equivalent to? The cosine is the right here, cosine is the x coordinate. Okay, so the x coordinate is root 3 over 2. The sine is the y coordinate, which in this case is 1/2. And the tangent is the sine over cosine. So 1/2 over root 3 over 2. When you divide by a fraction, it's like multiplying by the reciprocal. So dividing by root 3 over 2 is like multiplying by 2 over root 3. The 2's cancel. I get 1 over root 3, which when I rationalize is equal to root 3 over 3. Okay, and once we find these, we can find their reciprocal ratios as well. So the reciprocal of cosine, we just flip this. We get 2 over root 3. And again, when you rationalize that, the shortcut for rationalizing with square roots is if you divide by the square root of a number, it's equivalent to dividing by that number itself, the number that's in the radical, times the root itself. So 2 divided by root 3 is like saying 2 times root 3 all over 3. So there is a shortcut to that. The cosecant of 30 degrees is the reciprocal of 1/2, which is 2. And then the cotangent of 30 degrees is going to be the reciprocal of this. And again, if you just go to sort of this form right here, 1 over root 3, and we take that reciprocal, we get root 3 over 1, and that would be your cotangent. Okay. So that's the 30-degree angles. We can do the same kind of thing with the 45-degree angles. If we look at this 45-degree angle right here on a unit circle, so the radius is still 1. The pattern for a 45, 45, 90 triangle is x, x, x root 2. So if we know that our hypotenuse is 1, if you recall from geometry, the shortcut to finding the length of each leg is you take the hypotenuse, divide by 2, and multiply by root 2. So you have 1 over 2 times root 2, gives you root 2 over 2. The other leg's the exact same, which means when we plot the coordinates here, we have root 2 over 2 and root 2 over 2. And once again, we can identify these common trig ratios of 45 degrees. So the cosine is root 2 over 2, the x-coordinate. The sine is root 2 over 2, the y-coordinate. The tangent is number over itself, which is 1. The reciprocal ratios. Here we take the reciprocal. 2 over root 2 is like saying 2 root 2 over 2. So we can reduce or cancel the 2's, and we get just a root 2. The cosecant of 45 degrees is going to be the exact same thing, root 2. And then finally, the cotangent of 45 degrees is the reciprocal of 1, which also happens to be 1. And then the final one here, when we look at this 60-degree angle with a radius 1, we still have a 30, 60, 90 triangle. So we don't have to do anything different than what we saw here. Opposite the 30 degrees is 1/2. Opposite the 60 degrees, root 3 over 2. And so when we look at the coordinates of that point on the unit circle, x coordinate of 1/2, y coordinate root 3 over 2. So cosine is the x coordinate, 1/2. Sine is the y coordinate, root 3 over 2. The tangent is sine over cosine, so root 3 over 2 divided by 1/2, which is like saying multiply by the reciprocal, 2 over 1. The 2's cancel, and so the sine of the tangent of 60 degrees is root 3. And then when you find the reciprocals, secant is the reciprocal of 1/2, which is 2. The cosecant is the reciprocal of root 3 over 2. So here you get 2 over root 3. Dividing by root 3 is like multiplying by root 3 and dividing by 3. So you get 2 root 3 over 3. And then finally, the cotangent of 60 degrees is the reciprocal of root 3. So 1 over root 3, which again is equivalent to multiplying by root 3 dividing by 3. So we went through and derived each of these. These are things that are going to come up on a number of occasions. You don't necessarily have to memorize these. You're not expected to just know, like, this is this. But you should be able to recreate it and derive it the same way that we did right here, if and when it's necessary. Okay? So for these two questions right here, the cosine of pi over 6 is equivalent to what? Pi over 6 is what degree measurement? Pi over 6 is 30 degrees, so the cosine of 30 degrees we see is root 3 over 2. And what about the cosecant of 60 degrees? We established it. It's 2 root 3 over 3.